Hello everyone, now we will discuss the questions on subspaces. Text. Consider the real vector space V over R cube and the following its subsets. S equal to xyz belongs to V and x equal to y equal to 0. T xyz belongs to capital O V, x equal to 0. These are the subspace, but z non-zero, so it not be subspace. So option D is the correct. Now if V equal to R cube, xyz belongs to R, W equal to xyz belongs to V, and x minus 2y minus 3z equal to 0, then which statement is not true? Not true. So W is subspace of V. These W are subspace of V because x minus 2y minus 3z equal to 0, as we discussed about in tricks of subspace. It is true. Alpha beta belongs to W, it implies that alpha plus beta belongs to W, and alpha beta belongs to W, it implies that alpha minus beta belongs to W. These are the results of subspace in the necessary and sufficient conditions. The fourth result is W is not subspace of V. It is not true because W is the subspace of V. The next question is, suppose x equal to a b c d, therefore a b minus c equal to 5. It is not true. It is not subspace because it is equal to constant term. A equal to b plus c. It is subspace because it can be written as a minus b minus c equal to 0. Z equal to a b c d is that b equal to 0, c equal to d. It is also subspace because it can be written as c minus d equal to 0. Which of these subset of vector space R4 is our subspace? So first, x is not subspace and y and z are subspace. So option B is the correct answer. Now the next question is, let R be the set of all real non-empty and R square is equal to x1 x2 is that x1 belongs to R and x2 belongs to R. Then which of the following is subspace of R square over R? First of all, x1 x2 is that x1 greater than 0, x1 less, x2 greater than 0. It is not subspace. x1 x2 is that x1 less than 0, x2 less than 0. C is x1 x2 and x1 belongs to R, x2 greater than 0. And fourth is x1 x2, x1 belongs to R. These are subspace, but all these are not subspace because in the subspace trick we have discussed that x1 less than equal to 0, greater than equal to 0 are not subspace. Here can be x2 or x1 also. Now the next question is, let V be real vector space of all mapping from R to R. A equal to f belongs to capital O V. F minus x equal to fx is that even function. B is equal to f belongs to V and f of minus x equal to minus of fx. Then which one of the following is correct? A is subspace of V. Even and odd functions are subspace, as we discussed earlier. A is subspace of V, but B not subspace of V. It is wrong. A is not subspace of V, but B is subspace of V. It is also wrong. Both A and B subspaces of V. It is true. The next question is, let V be vector space of all n cross n real matrices over R and W1 W2 be the collection of symmetric and skew symmetric matrices respectively. Then we have already discussed that symmetric and skew symmetric matrices are subspace. So now discuss the option. W1 subspace of V, but W2 not subspace of, but here W1 and W2 both are symmetric and skew symmetric matrices, so these are the subspace. It is also wrong. W1 not subspace of V, but W2 subspace of V. It is also wrong. Both W1 and W2 subspaces of V. It is true. Neither W1 and W2 are subspaces of V. It is also wrong. Now we discuss the question, let vector space R square R consider the subset A x y x plus y equal to 0, x y x minus y equal to 0, x y equal to 0 and x by y equal to 0, y non-zero. The C and D are not subspace because multiply and divided are not subspace, but plus and minus equal to 0 are subspace. So A is subspace and B is subspace. First and second are true. C and D is not subspace. Now we discuss the options. Choose the correct code is only first and second is true. It is true. Only third and fourth is true. It is false. Only first and third are true. It is also false. Only second and fourth is true. It is also false.